Okay, hello everyone, welcome to this 8th stream on the OpenHT project. Quickly, a very short description of what we are gonna do today. So this is the board as we left it in the previous stream. And main thing that we still have to do is maybe route a few tracks for the power supply, for the battery and so on. We still have to choose which battery connector we want to use. And finally, we will have to do the finishing touches for the board. So what I call the finishing touches is maybe moving a few tracks so that we are sure to follow the best practices when it comes to PCB design. So for example, when you look at this, this can be improved by having some space for the ground plane on the top to go in between those two signals and so on. So this is what we are going to do. This kind of work can be pretty slow and time consuming, but it's required in order to have the best possible design. It will both improve the sensitivity to noise and also reduce the noise that the circuit can generate regarding other, well, it can be noise that is generated by the circuit and having an effect on other parts of the same circuits, or it can also be noise generated by the circuit and disturbing other devices around. So that's what we are going to do. Yeah, the M17 t-shirt, I think it's gonna be coming in the following days. Maybe I should get it at Friedrichshafen. Yeah, so Mike is still okay. Yeah, it's still, is it better now? Yeah, okay, so I guess audio is gonna be annoying today. Yeah, we've seen it happen. Okay, I get it that you've been surprised, Fuchir. Okay, no, okay, it's good, not good, okay. Well, I see that I also have a few things to reroute. Like here, it haven't been routed properly. Which signal is that? Okay. So this can be fixed like this. Why is this not? Ah, I see. Okay, so the plane wasn't being filled because it was the same priority as the ground plane, and the ground plane was taking its place. Okay, nothing to worry about. This easy fix too. So now we have a test point for the 1.8 volts. The battery part, I still want to wait a bit for that. It will be easy to do, but we will have maybe to discuss quickly what kind of connector we want to use. Okay, same problem with the battery plane right here. We are gonna put it at level 1. Okay. Okay, so yeah, we will continue. So one thing I I also wanted to do is maybe we could try having a shield around the transceiver and around the power supply part. So the thing I was imagining was maybe having kind of the metal lid that you would place on top, except that this being the proof of concept and for us kind of a development board, we need to have access to the components below it. So we would have to have a look for a shield that is in two parts. So you have a frame that you solder on the board, and then you have a lid that you can clip and fix, set on the frame. And yeah, the goal of this shield would be twofold. First, it would help mitigating noise and sound, so having better noise immunity and again reducing the noise around us. But also this would very much help in protecting the board against ESDs or some things like that. So ESDs, electrostatic discharges, basically sometimes when your body is charged up with static electricity, you can touch a component and kill it, and you won't even see it, hear it, or anything like that. It's kind of a silent killer. And so when this happens, it suddenly stops working and you don't know why. So I would like to avoid damaging components like that. And yeah, I think it would help us, even though all the pins around wouldn't be protected and some are directly connected to the ICs, so it could still damage the board in these cases. Anyway. So yeah, having a look at what we can do to improve this. Okay, we have ground here. Maybe I will move this a bit so that... Oh, what? Why does it move like that? Okay, so now we have a sliver of ground and yeah, a bit more so that we could place a via right here. Yeah, we need to move it a bit more. Okay, great. So it's important to place vias in places like these because this can basically behave as an antenna if you want. So you have a long stub right here which can resonate, or yeah, this could be floating, it not being tied to the ground properly, and this can also create its kind of issues. Again, it's not breaking issues, like it won't break the board, but it's less ideal. So we should avoid that if possible. I will try to maybe get these components a bit closer also, because we have all the room we need right here. And this needs... Okay. That, and we also can break the track so that we can remove that. Okay. Can we place... Yes, via right here. Perfect. Okay. So same thing here. We want to touch the ground plane like this. Oh yeah, this is the 3.3 volt feedback for the yeah, I will route that like this then, and then okay, maybe this can move a bit, or yeah, I'll avoid moving these. I don't know if Jay is watching. Are you watching, Jay? Okay, I get it that he's not watching. So yeah, I will try to avoid moving unnecessary components, especially the one which might influence the design of the 3D case. So yeah, this. Okay. I have a lot of, yeah, I have often the ground plane going under the SMD components. This is not ideal. It would be best if we could avoid that. Yeah, we still do even like this. And we might have also to move a few vias here and there because of this rule. Just making sure that we don't have any area being overridden by the ground. It seems it's alright. Oh yeah, I remember that one of the things we had to do is moving the push buttons on top so that we will save an assembly. Like this, but is it? Yeah. Okay, so this should be just what we need, except that we have now this track, which needs to go on top. Where does it need to go after that? Okay, we can still route that on the bottom layer, but you have to place a via next to the switch. Okay, great. And same goes for here. All right, good. So for the buttons, this is okay. We'll just quickly check in the 3D viewer. Yeah, okay, great. Oh, one more thing that we're gonna need to do at some point is all the silk screen labels for the SMD components. We really need to fix that so that it's readable and exploitable. Like this, it won't do it. And it's better to have those labels printed for when we debug. Okay, so right here, let's see if all the via leave at least a sliver of ground plane in between them. So this is not good, for example. We can maybe use a smaller grid. Do we want to remove vias under the RF filters? I don't think so. Well, one second, I will just move that. Okay. So I guess you're talking about these vias. I wouldn't remove them. They are part of the default design, and I don't think it's a bad idea to have them. Except that, yeah, maybe it could make it harder to solder. We would need to see if Acer does support capped vias. If they don't, we will have to remove them. Oh, well. Yeah, anyway, we still are gonna have the problem with all the QFNs. And these, we need the vias. So, yeah, we'll have to check that. What do they say about that? Okay, they do not support tinted vias. This is a problem, kind of. Yeah, there are a few things that I don't really like about. They enlarge themselves the solder masks, so that's unusual. Usually you let the designer have that. Yeah, good idea. We can have a look at the data sheet of those. Um, yeah, if it is, then it's better to keep them. Yeah, is my audio low or am I okay? Yeah, it seems that it's slow again. Yeah, okay. It's still not fixed. It should be good, I guess. Is it? Or not? Huh. Okay, now it's good. That's very weird. I have to reduce the gain, then set it back to its correct value, and then it fixes it. But for the previous bug that I had where it was increasing the gain, I had to disable it and re-enable it. I really didn't get it. I don't see from where it could come. Okay. Yeah, so we will have to discuss with Acer if they can manufacture the board as we require it, because for the it kind of requires tinted vias and they do not support it. So that means that we might have problems where the solder from the solder pads of the QFNs is gonna flow and basically, yeah, go to the other side of the board instead of being between the pad and the board. So this is problematic. Yeah, we will have to see with them, and if it's a problem, we might have to go somewhere else for the production. But I don't really like this idea because it can be quickly very expensive. Yeah, Eisler doesn't support tinted vias, so we'll have to see. I don't know how much of a deal breaker it can be actually. Okay, and right here we also need more clearance.
Let's have a look also at the kind of shields that we could have, and if we can already select the size and try to get some clearance around so that we can place it. Okay. Okay, so I'm having a look at Mauser. Okay, like this. Hi, Bastien. Yeah, that's the thing I was saying for the tinted vias. I don't know if we need them so bad, but for the FPGA, for example, I think we won't be able to do without, because there is simply no ground pin. So, or we would need to place the ground vias around here, and that could be feasible. But it usually helps in heat dissipation and correct ground. So, yeah, okay. So I was looking at the kind of shields that we could have. Where would those be hidden? So they use those. Okay, so it would be like this. And okay. Yes, Bastien, I saw your post on the Matrix server, and it's great. Yeah, I don't know if you see where the school is located, but it's yeah, near the bus stop in Sartillement, in the village. Okay, so the kind of thing that we would be looking at for the shielding is things like this, which is not that expensive. But we would need quite a large one for the power supply. So 3.2 by 3.2 centimeters, and I don't know how it would look like. Maybe let me oh well. 3.246, yeah, it's close enough. So this is, yeah, maybe not put it in this layer, but use this, for example, or another one so that it's another color. Okay, so, well, actually, maybe we could fit one in a 3x3 shield. yeah, we would need to maybe modify the design a tiny bit so that we can squeeze it in. I think this is feasible, and this seems to be quite a standard size. Otherwise we have larger one, but yeah, it might be too large. 26, 32 again. This is in inches, but I think this is too small. Well, it's about the same size actually. Still, I think it's so. Yeah, 32 millimeters. Or we have this one, which is 44 by 44. A bit more expensive though. Yeah. Yes, the RF part we must shield that too, but it will be easier because just have a look. It's already fitting in, so we might have to rework it a bit. But yeah, maybe we could order 2 or 3 shields and place one on top of the RF part, one on top of the FPGA, and one on top of the power supply. And I think this would be the best. Yeah, I will just ask you to give me a minute. I will be back. Okay, I am back. Yeah, that's the kind of break that can't wait. Yeah, so okay, we should think about our priorities. I think the first priority would be to move things around so that we have room for the shield, because if we start doing the very final details about where we want to place things and all, the vias and so on, we might have to redo that after we move everything for the shield. So, yeah. However, how could we do that? Maybe we can first do something like this. The height of the shield, I think we have several that we can pick from. I will have a look. Okay, I just want to like this and like this. Okay, okay, great. This is how it should be. Right. Yeah, I wanted to have some room for getting this a bit lower and all, but with these vias I will not be able to. I first will move this. Yeah, I think I will need to okay. And we don't even need the top track. It's connected by the third layer. Great. And so yeah, okay, I'm gonna need the schematic to see what are the components I'm looking at. Okay, so this is the divider for the feedback. This can move here without any problem. This. And this can okay. Oh. Okay, and so now we should be able to move that. Maybe push these around. maybe a bit higher, like this. And we could then, yeah, no, we still need that to be a bit higher. And now we have room for a via here, one here, one here, and one here. Great. And we can even add one here. Amazing. Oh no, I know. I can do this. And so this can drop a bit, and oh no, not that. Yeah, I can imagine all the spurs going down with each ground via play. That's the spirit. At least that's what I hope would happen. It would be quite amazing being able to see that live. Okay, then this doesn't need to be that tall, and this, however, needs to move. This via can go right here. Okay, why is my ground plane... Is my ground plane higher priority than this one? Not even. Is it because... Yeah, okay, that's why. Okay. I also have this... Getting confused with all the planes. Yeah, okay, this one needs to drop like this. And then all the vias, maybe I can select them all like that. Okay, and then all that's left to do is move, no, maybe first move the capacitors. So this ground area is kind of useless because we have ground everywhere anyway, but yeah, we're gonna keep it. Maybe we don't need that many ground vias then, because the zone is gonna be a bit smaller. Okay, how does it... Oh no. Yeah, we still need a bit more compact design. Maybe we can do the same thing here. Okay, and this. Okay, so we have our vias. Great. This can be connected right here. Should be good. And now we can move this like that. Okay, I want to. This is too high. We still need. We need to have the ground connected properly. Well, it's just the slow start capacitor, so it's not like we really need a very good connection to ground. So it should be good enough like this. Also, I worry that these are too large and that we are not going to be able to solder these pads properly. Why did I pick this thermal characteristics? I don't know. Anyway, we are going to have to have a look at this later on. This is not good that way. It's going to sink all the power from all the heat from the pads, and we won't be able to hand solder it properly. This might be not enough, maybe. Let's see. If I first move all of these. Come on. And those two are in the way of the track on the third layer, so we are gonna need to, we will need to move it. Oh no, it seems that, yeah, okay, I didn't move it correctly. Let's try to, okay, stay aligned. Then we can move this edge up a bit, this too. Okay, great. No, actually, how did I do it? Yeah, okay. We will try to have a bit of ground going here, so I need to raise this a bit. Yeah, great. Okay, so now, hey, this could be enough. Actually, this could be good. So yeah, nice. We would have to relocate the 1 volt LDO so that it falls under the shield. And this is yeah, the load switch. We don't have to have it under this. Yeah, I will not put it under the shield because we should avoid being completely crazy, and at some point, if we have everything under the shield, as soon as we are gonna want to probe something, then the shield is gonna be in the way. So, because as you can see, there is still something on, yeah, it's not completely open even when you, so yeah, let me just open one, and yeah, this one for example. So there is the cover that we can remove, but then there is this kind of crust that is in the way, and I think we could cut it if needed so that we have a better access to everything below, but yeah, I would like to avoid that. So it shouldn't be in the way if possible. So it's 32.46. Can I just yeah, okay, it's even a tad bigger. Nice. Okay, so then we would do something like this about that. That also means that this needs to be relocated to somewhere else because under the shield is not possible. This needs to move up a bit so that it's under the shield. And also the test points, they all need to be under the shield. So this one, it's 2 mm thick, which is not much. But I don't think that we are gonna have anything higher than 2 mm. I don't think. Usually these are about 1 mm thick. Oh no, the coils, they are gonna be much higher than that. What are the components that I picked for the coils? Yeah, this could be a problem actually. I didn't think about the coils. They are shielded, the coils, but let's see. Hey, since when is it not recommended for new designs? I picked it like a month ago. Let me just have a look at the size of this one. Oh yeah, height, it's 3 mm. Okay, it's not that much, but it's still too much for this one. Okay, height. Okay, let's pick everything up to 6 mm. Should be way enough. Yeah, but maybe it's when I selected it from DigiKey maybe, and so maybe they do not have this warning. Ah, they do. Okay. I don't want to swear, but I really should. Anyway, can I know from when they decided that it was not recommended for new designs already? Maybe it was in the meantime, or maybe I just overlooked it. Yeah, they don't say. I mean, it's 2021. Please. Do they have? Nah. Well, this is gonna be annoying because we will have to pick a new one, and I don't know if we are gonna be able to find a new one with the same footprint. So we might have to change a few things, but I really don't want to keep that one, because the goal of this proof of concept is to reuse as many components from the first design to the second design. So that means that if we have to change this in between, then we kind of lose the purpose of having done the power supply on the proof of concept. Yeah, it's not end of life, but it's yeah, as they say, it's not recommended for new designs. So maybe if, let's say that in a year they stop producing it, I don't know how long they would wait before stopping production, but if they do that, then it's still annoying. So let's say that I will have a look at that, but I will do it off camera, I think, and then report my findings in a stream. Okay, anyway, those are also 3 millimeters. This one is 3 millimeters high, I think. Which one did I have a look at? I think it was the... Yeah, this is the one for the second buck, so 1.8 volts. And this one, it's also an R&D, and it is also 3 millimeters high. Okay. So if we find a shield which is 32 by 32 and at least the correct height, it would be nice. Why do they give only one dimension? Okay, 39 by 38.2. Also try to sort them by price so that we don't have like 10 bucks on a shield. Oh, nice. It's all in millimeters. Oh no, we have the inches in between. Okay. Let's say... Oh. That's not much. Maybe we can still accept. So basically what... Yeah, we could use also a non-square one. Okay. This can be moved to be outside of the shield. We'll... Okay, yeah. We'll move that to be... tracks. And also vias. Oh, I can figure out how I should rotate it. Okay, like this. Come on. Okay. Bottom layer, we need to fix that. Okay, so it should be all good. Yeah, maybe we can also try, yeah, okay. Making some space around here. So that we can have this jumper somewhere too. Okay. Can this... Sorry. Hey, it does fit. Great. This one does need to go out of the shield too, but maybe we can put it around where the 1 volt test point is currently. Okay, I'm trying to think in advance where the tracks are gonna go. This needs to move. The 1.8 volt, I can take it right here. And also... Oh yeah, no, this is the 1.8 volt for the pull-up, for the enable pin. So this doesn't need many vias. However, this one, how am I gonna... Do I need to move things around? Yeah, but I have signals on the second, and the third and fourth layer, which I should be careful about. Actually, I can also take this and move it on the left a bit. I should try to not go too far on the right, otherwise I'm gonna have other troubles. So yeah. Yeah, this should be good enough for now. And I can also use the third layer to route the VCC track. Okay. Okay, so now we have the 1 volt, which is under the shield, so that's great. And we can even place the test point right here. Oh no, it's, oh yeah, and this is the ferrite bead, I think. Yeah, but we can have the ferrite bead right there, it's not a problem, I think, because except for the short part here, it will always be in between ground planes, so kind of shielded, so it's not a problem. I will just move that so that we can have, yeah, okay. Then the 1 volt test point, maybe I should update it so that it's VCC and not 1 volt. Yeah, I think it would be, it won't change much. But anyway, it's better to have them on the, oh yeah, but yeah, 1 volt is used only for VCC anyway, so I will check. So in the schematic I have the FPGA and yeah, okay, 1 volt ferrite bead VCC. Then I should just add a test point here. Thanks, Voishir. Have a good night. Although maybe I can. Yeah, no, I should really have a test point. No, not this one. It was here. This one. Okay. Nope. FPGA, and simply add a test point. Okay, and this should be enough, so just assign a footprint and see what I assigned to the previous ones. This. Okay, import. And we will place it right here. Great, okay, so VCC test point is placed and out of the shield. Fuse should be out of the shield too. This should be out of the shield. This and this too. Okay, so maybe we can actually use somewhat smaller shield. So what would this be? It's 30 millimeters wide. And if we didn't use, which maybe we can try moving again the 1 volt LDO, and then we are at 24 millimeters, and this will make it easier to find the shield. So yes, I should try that again. Okay. Okay, PCB design is an iterative process, so yeah, we are expected to restart things from time to time. Hi, DL9MGJ. Welcome. First time I see you around, I think. So yeah, if this is the case, we are doing the PCB design for the OpenHT project. Basically trying to do a fully open source handheld transceiver, and we are using KiCad for that, so that even the source files and the software to modify the source files, everything is completely open source. Thanks. Okay, I message you, okay. Where should I? Okay, I will place a test point right here actually. Okay. So this board is 4 layers, because yeah, as soon as you have RF tracks, so for example right here, you basically need 4 layers because it's way better for the impedance matching of the tracks. It's also much better when you have dense design like these, and it also allows for better ground layout, which is gonna act as a shield around the board, and it improves the performances and the behavior of the board and the circuits. If you look at the AMC and EMI things, it's all better this way. So that's one of the reasons that we use a 4 layers board. However, for the next iteration, I hope that we will be able to keep 4 layers because it's easier to design and cheaper, but maybe we will have to go up to 6 layers. We will have to see that once we know all the functionalities of the board and so on. But when you will have the RF part, the FPGA, the MCU, and the power part and so on, we will have to decide on everything for this, because yeah, it can be quite difficult to route everything in a small 4 layers board. Okay, this part is quite ugly. Could I try to improve it somehow? Yeah, this kind of board, FPGA and LPDDR4, yeah, you are gonna need a lot of layers. And in our case, we use many layers because we need the surface to route all the tracks and so on. But sometimes you have so many different reference planes and type of impedance matching for the signals that you have that, yeah, you basically need to have a load of layers so that you can have some layers which are very quiet and don't have a lot going on, but those signals will be very sensitive. So this is, yeah, the kind of things that you might need. I would like to remove this and find a way to route it on layer 3 up to here. So I will need to delete that, modify it. It allows me to route that like this, and this. Okay, oh, that's much better. And so now I can have a via right. Yeah, excellent. Okay. Freeze. The computer is acting up. And via right here. Perfect. Okay. So things are clearing up a bit around here. That's nice. However, I still have to place all this. Okay, I have to redo everything, I guess. But yeah, Mizinski. So you say that there is no RF on the boards, but actually it's kind of hidden RF because the signals for the LPDDR4 are in the RF range basically. So it is kind of routing RF signals, except that it's not. It won't leave the board, but it's the same kind of requirements. And usually the impedance matching is at higher impedance than the 50 ohms. Yeah, lots of meanders. This is not for the impedance matching, of course. It's for the delay and the time. So like we have here, even those are a bit overkill, but we did it because we had the room and it was nice doing it. But this is for the delay, so that all the signals arrive at the chip at the same time. Yeah, impedance matching and delay. I have never routed something as complicated as LPDDR4 or anything like that, but that must be quite a challenge, yes. Okay. So do I have the 45 degrees settings set or not? Yes. why I can't have it be a 45 degrees corner. I hate that. I want that to be 45 degrees, please. Why is it? Oh yeah, I guess I moved it and then I changed the grid size again. What? Ah, it's a nightmare. Okay. Why does it have to be so hard? Oh, okay, anyway. Maybe I can just route it like this anyway. So this is the ferrite speed. So why? Let me have a look quickly. So this is the output decoupling capacitor. Oh yeah, and this is one of the resistors of the divider bridge. Yeah, okay, I get it now. Okay, so it seems that we are able to fit everything under the shield. Great. Except that, yeah, I still need maybe we will need to enlarge it a tiny bit, but I think that the standard size is 26 millimeters. So if that's the case, well, that's what I... Okay, let's... Oh yeah, okay, so what do they call... Ooh, so this is length and width, and yeah, okay, so I would need to pick. Yeah, okay, that makes sense. There is nothing above 32 millimeters. Okay, so we need it to be at least 32 millimeters long and at least 25 millimeters wide. Let's say I hate it when this happens. It freezes and then it ignores all my commands. Okay. There are not many pieces available. Okay, yeah, okay, I think, let me, okay, so yeah, we have enough room around this assembly so that we can have several type of shields, so that's great. I still need to route that maybe I can like this and also like this. This isn't ground, this is VCC. No, this is not VCC, it's 1.1 V8. Okay, so this is good. I will just add the ground vias. And maybe this doesn't need to be that wide. Oh, oh shit, I completely forgot about that one. I need to move that aside like this. And fix that. Okay, yeah. And also this can be a bit different. Yeah, this doesn't... Okay, no, like this seems good. And ground vias do not create an opening in the 1v8 plane. Okay. And the mic is still working. Great. Okay, so vias to bring VCC to the third layer. Can I place 2 vias or is it too much? Okay, I also will need to no, this. Okay, yeah, like that. I would like to have a ground sliver in between those two signals. Okay. And like that. And then we would need ground via here and also one here. So that we do not have long, thin ground part of pieces of planes. Okay. Yeah, okay, so as I said, the finishing touches, it's a process which is quite slow and time consuming. And also requires to think a lot, so it's not the most fun part to watch, I guess. So that's why I was thinking that maybe I could also try to record my screen, do kind of a time lapse, showing everything very quickly, so that you do not have to sit in front of me thinking for tens of minutes at a time, which can be a bit tedious, maybe. Okay, yeah, still have to do this. I still can't. Yeah, okay, maybe I can just get this a bit closer to the decoupling capacitor. And then, do I have the room for an additional via? Or maybe I can also do like that. And then I have the room for a second via. I just need to move it a bit more. But then I create an opening right here. Okay, maybe I can get this via a tad closer to. Okay, great. Bye, 73s. See you next time. Yeah, I don't like that being this way. Okay, great. That should be enough. Yeah, that's lots of very slow and not exciting processes, but that's part of the deal. Okay, so now just go on third layer and yeah, perfect. Oh, and it kept all my tracks, even the redundant one. Great. I need my decoupling capacitors vias, so let's put one here and one here. Yeah, I'm gonna put vias right here. And for good measure, one here and one here. Great. Okay. Okay, so for the shield, it's mostly done. I will try to pick apart and so on later on, out of stream, because I still have to do a few things for this part, so I do need to decide if I will keep these inductors or not. And yeah, I think I still had to decide whether I want to modify the loop compensation circuit, but this is very, very hard to do, and potentially involves a lot of math, which, yeah, if I do, I will have to prepare it before going on stream, so yeah, but we can potentially prepare for everything, every possibility, by just having the footprints and then change the components. But I do need to see if I need to, maybe I need to add more footprints than the one I have, so yeah, but that's another story. Okay, this power supply part is starting to be quite nice. Oh no, I have a very small opening right here. Yeah, it's... Okay, great. Okay, amazing. Yeah, let's have a look layer by layer. Sometimes it helps finding things that we don't want. So yeah, we don't have any long sliver without any vias except here, but it's not, I don't think it's a problem. We have one here and one there, so not a big deal. Here is good. We have what we need here. Okay, so it seems to me that regarding the power supply, first layer is good. Third layer, do we have any? Yeah, it's a sexy board. We have two grounds here which are inside the battery plane. That's not ideal. Yeah, I think I'm gonna move them like this. So we are not at a few... Yeah, so we moved that by 0.5 millimeter, so it's not that big of a deal. And it's connected there, so yeah, okay, it's great. And the battery plane isn't too eaten by this incursion. Okay, so we don't have any islands. Oh, this is not great. It's better like this. And so we can put a few vias every now and then. Okay, great. Okay, I will also need right here. Amazing. Yeah, perfect. Yeah, this is very large area with not many grounds. Okay, what is this signal? Yeah, maybe we can move it a bit. Okay. Great. Here it would be nice if we could have a ground via, but this is the PGA. Could we have, like, could we do something like this and have a via right here without disturbing everything? I don't like this idea very much. Vias right here could mess with the assembly process and make it more difficult, and so yeah, we could have some boards failing to assemble properly. Okay, well, I'm not gonna be much longer. So yeah, oh yeah, I have been streaming for 2 hours already. Well, times flies quickly. Yeah, still gonna have a look at the bottom layer if we have anything that we don't like, but it seems that it's alright. Bottom layer is not very... there is not a lot on it, except right here, where we will have to move things around so that we don't have that many dark zones, dark areas. Okay, I think that's gonna be it for today actually. Maybe just have the 1.8 volt via right here. Okay, yeah, let's leave it right.
Okay, so open git client. It's this one. Okay. Oh yeah, I also need to update this. I'll do it in the end. So, how did I call my okay, whip PCB routing, and finally oh yeah, okay. No, I'm getting lost. I'm tired. It's late already. Okay. All right. Let's push. Oh no, I need to update the artifacts. So the schematic PF, and while I'm at it, the step file too. All right. Okay, well, thank you everyone for being here tonight. Well, tonight for me and today for, let's say, overseas. It's still very nice having people around while doing this. Don't hesitate to ask some questions, as many as you like. And in the meantime, see you the next time, or maybe on the M17 Discord. So yeah, I do believe that the link is in the description in case you want to join us. So don't hesitate to click. And you can also ask any questions you want right there. So see you next time, and 73s to everyone then. Bye bye.